So why steel bars in a reinforced concrete column are provided near the edge? As you can see in these figures that all the reinforcement, the longitudinal reinforcements of the RC column are provided near the edge. So what is its purpose and why is it not given somewhere else in an RC column? Now, as we know that columns are compression members and are primarily subjected to axial compressive loads, but columns can be subjected to torsional moments in addition to flexure, axial and shear forces during earthquake excitations or any other lateral forces. And also load acting on a column are always at some eccentricity, as perfect alignment of axial load is not possible, which results in some moment in the column. So these eccentric loads and other moments means that some portion of the column cross-section will be in compression while some portion of it will be in tension. As you can see in the figure here, that half of the forces or half portion is in compression and half is in tension, and because of this the concrete and the steel provided, they will be both in compression and tension. Let's confirm it with a practical example. I have designed a 3-story residential building on E-tabs. We will import a column, any column, to CSI call, an application used to design column. We will import it in CSI call and then see at different load combinations in real cases how the column section behaves. So these are the combinations, like dcon1 is 1.4 times D, where D is the dead loads. So we have all these combinations which are used in the designing of the structure. D is dead load, L live load, S is the snow load, and then we have the earthquake load. This building, it was to be constructed in a seismic active zone. That's why we had to consider the earthquake loads. So our model is now imported. So here the blue color shows the beams and the orange colors or brownish color, these are the columns. Let's select a column. I think we should select somewhere in between because these columns mostly have the heavy loads acting on them, those in the center. So I've selected this one here. We will import it. So this is our section, our column section. It is 12 inch by 12 inch. And then we have 8 numbers of bars with a dia number 5. Now let's check if all the loads are imported or not. Here we have the design loads. So here we can see all the loads have been imported. Like for decon 1, we have 84 kips of axial load. Now decon 10, this was the governing combination. So we have 46 the axial load, 0.2 and minus 0.9. Now let's check the stress. So for decon 1, we have this stress on our section. Let's go to decon 10. Here we can see that the load acting is at some eccentricity, some 7.44 inches from this side. Let's see at a 3D view. So this is how the load is acting on the concrete. Now let's look at the stress in bars. Now here's the interesting thing. 5 of our bars are in compression. You can check the colors right here. Yellow, blue, these colors, they are a positive sign which shows a compression. While the other 3 these three. They are in tension. The minus sign shows tension right here. Okay? So in this way, by distributing our bars on the edge, we were able to take advantage of their positioning. We saw that our column was both in tension and compression on the actual load combinations, where three of our bars, they supported the section, the column section, in tension, while the other five, they supported the column in compression. So this is why steel bars are provided at the edge of an RCC column. In addition to compression and tension, these steel bars around the edge also contribute in the torsional rigidity of the column, which can help the column in resisting torsional moments in case of an earthquake. So if you liked my video, give it a thumbs up. Thank you so much for watching.